unmute the microphone and see if it works. And just checking, make sure it's working. All right, sweet. Let's get going. Hey everybody, hope you're doing well. Going to be going into some of my favorite serialization libraries that I use on Zephyr. One is included and one is not, but probably will be in the near future. So fingers crossed on that one. But in the meantime, you can still use it. There's just some little extra work you gotta do to get it working. And let me get to slideshow controls. So, if you haven't already, subscribe, hit the like button. I really appreciate it. And leave a comment. Let me know if this is useful for you and if there's anything you want to see. And special shout out to Androby. You've been at the last couple live streams, so appreciate you being here. And everybody else, of course. Feel free to say hi in the comments too. Let's get going. So serialization is the process of basically kind of boxing up your data on your device and then sending it over some type of transport layer, whether that's Bluetooth or LTE or Wi-Fi. Essentially makes it a lot easier to you have this like abstract data. It's like, how do I get this into some type of format that the other end will like accept? So that's the type of thing that you need to work out on both the device side and the server side. Kind of important to know on the server side what it's expecting to receive from devices out in the middle of nowhere, and then on the device side, obviously you need to know what format to send. So that's what we're talking about. We're talking about serialization. And the idea here is that when you create specific serialization setups, essentially they're called codecs. So you've probably heard of codecs in the past in any type of programming world stuff. Well, we're talking about making a codec for your system, for your device, or for your particular use case. We'll just be talking about one piece of kind of creating a codec on both. We'll be talking about QCbor, which is a cBor library, and cJSON, which is a JSON library, if you haven't noticed. And there are some differences here. One is more human readable, less efficient for space or size constraints, and then the opposite is true for QCbor, where it is not so human readable, but it's optimized for size. So. cJSON, it is the de facto JSON support in most embedded worlds. I'm sure there's other ones out there, but this is the one on Zephyr. It's included, so all you have to do is just enable it using your project configuration. The high-level API is intuitive, so you don't really have to do a lot of guesswork. You can just look at some of the basic samples, and you kind of glean what you need to do in particular cases. It can be used for both encoding and decoding. We'll be focusing on encoding in this live stream. Of course, if you'd like to see some decoding samples, please let me know. And maybe we can do another live stream about decoding or anything else to get in data from service or server. And of course, it is human readable. And all JSON is human readable to some extent. And that's just the way JSON is. The thing is, it's not so efficient, like I mentioned before. And then in some cases, you might be better off, instead of using cJSON, you might be better off just doing some string manipulation, depending on how complex your payloads are. If you have dynamic payloads, then cJSON is the thing. If you have more static ones, you might be able just to kind of serialize everything together with sprnf or something similar. So you don't have to have this heavy weight of a library built into your device for one kind of encoding of like a simple JSON blob. So something to keep in mind as you go forward if you are thinking, oh, should I use cJSON or just do it myself? So I've done both. If you're constrained on space, do it yourself. Here is the project configuration. This is the variable that you need to enable to allow you to use the cJSON library. And here's kind of the basic initialization. So this library, it's important to run this cJSON init before you start using it. I've shot myself in the foot in the past where I've tried to encode some JSON before running this, and essentially it will just error and get angry at you, and it's not going to be very clear as to what happened. This initialization function points the pointer of the allocator, your system allocator, your memory allocator, to whatever malloc implementation is for the RTOS. So without that, you can't allocate any memory. And in this case, this library does allocate dynamic memory. So if that's something you're opposed to, you can use something like QCbor, or I'm sure there's other options with cJSON where you can do it statically. I have not played with the static allocation part. Here is the basic case of kind of encoding a simple message. We're encoding a value called value, and the number is 1, 2, 3, 4. And basically what we're doing is we're creating a JSON object. So think of that call to cJSON create object as like the parentheses, the outer parentheses. So you're creating the outer parentheses, and then you're adding this object, which is called value, or this value that's called value, to that JSON parentheses, and you'll see what it looks like in a second with that value of 1, 2, 3, 4. Now, what you need to do, so we've added that value, let's say, and now we want to encode it into JSON and actually get a string output. So cJSON has a print formatted and print unformatted. Generally, for transferring data over any type of link, if you're trying to be somewhat efficient, you're going to want to use the print unformatted option rather than the formatted. And that will make sure that there's no extra white spaces or new lines or anything like that, and it'll save you definitely on some data usage for sure. And the bigger your JSON, the more white space and things like that in it you'll have if it's formatted. So better do it unformatted. And then essentially here is just making sure that we're getting some type of data. If we're not getting data, that means that something happened. Maybe your allocator, maybe you had no extra your memory on the heap, or there was an error encoding or whatnot. So could have been a bunch of things wrong there, and you can see, if the data returned by that print unformatted, which is basically a string pointer, if that's null, then you are out of luck. Then what happens at the end there is that the structures that get set up by cJSON to do the encoding portion just needs to be deleted, and I think it's just a dynamic free that's happening. Now, this is the data. This is as simple as possible. You have the value, and then you got the 1, 2, 3, 4 there. So you can see that kind of like aligns with what we were doing earlier. Here it's just like create that object. You're creating those brackets, and then you're putting the value inside the brackets. And you can also nest it. You can get pretty crazy with this library. You can kind of customize and make it the way you want. So in the end, this is a 14-byte payload. Unformatted JSON, like I mentioned, is preferred, and this is what, if I did formatted, I'm sure there would be some new lines and extra bytes in there that aren't necessary. And then, again, the data is living on the heap here, so you just got to make sure that you free it once you're done using it. And in Zephyr, RTOS, you're going to have heap for dynamic allocation, and it's just something you have to be careful with. So cJSON_free, which is just basically a abstraction to the free call, the k_free for Zephyr. So for QCbor, so that's cJSON in a nutshell, and just encoding a very simple, very simple blob of JSON. Now what we're going to do is we're going to code that same data using QCbor. Now jump back in. So what I like about QCbor is that, and we kind of discussed this actually last week, hit on it when I was chatting with the Goliath folks, is that one of the main reasons they chose to use QCbor instead of tiny cBor is that it's just the API calls are just much more enjoyable and usable and simple. And plus, decoding is a little bit more straightforward. I started using the tiny cBor library. I'm like, oh, cool, it's included with Zephyr, but it's frustrating, to say the least. It is a small library. It was actually, the Q is from, what is the Q from? Oh man, I just blanked on it. Big semiconductor manufacturer developed this library eventually, and then they open sourced it. So the Lawrence, I believe, he's the one who's kind of taken the torch. He was working there, and now he's doing it on his own and just maintaining the library, which is awesome. And it's fairly small. You can use it for both encoding and decoding. I've done that both. And then it is not human readable. So the products of the encoding is just bytes. So if you want to like look at it, you're going to have to use a tool to kind of like decode it into something that is human readable, understandable. And of course, it is machine data usage friendly. So there are ways to make your QCbor terrible and take up a lot of space where it doesn't need to, but it is a lot better than just standalone JSON if you just put the same values in there, and you'll see that in a second. The only downside is it's not 100% Zephyr friendly at the moment. It does not include it in the vanilla Zephyr. You'll have to either manually import it into your west.yaml and then do some CMake magic on the back end, which I've done. Also, Goliath has a fork of it where they actually just added the CMake files and the kconfig files in, so you could actually just import it as a library. Very simple, and that's probably the recommended way to use it. If you look here, this would be the entry in the west.yaml file. So let me just put that back. You might be able to get away with a different revision name or just the name of the branch, but they put that specific hash for some reason. Yeah, it's just pulling it in, and that just becomes another dependency in your project. Again, once that's pulled in through your West YAML, you can see that all you have to do is just configure QCbor and set it to Y. And then what we're going to do is just encode those same values. So we're setting up a static array, and it's going to be 256 bytes. And then what happens here is this library uses a context or a construct called useful buff, and it's just setting the data size, the length, and also the data pointer to whatever kind of data blob you're using. And then the next step is kind of opening those brackets, kind of like before, except there's no brackets. We're creating a context which basically follows the encoding process throughout the whole thing. And then we're just going to start initializing with that useful buff that we were created before. So we're just setting the stage for encoding values. And then if you look at the next step is just we're going to open a map, which basically is a key value pair, and then we're adding bytes to the map. Actually, it shouldn't be bytes; it's add int to map. I was copying and pasting and didn't change that, but it should be add int or add uint to map. And then you're setting the name of it, and then you're setting the value of it, and then you're going to close that map. And essentially, you're going to finish and get that size of the encoded blob. Now, one thing that you can do here, which is pretty neat, is that some decoders actually support packed cBor. I use a particular library on the Rust side, which basically, instead of setting your value as a string, you can actually set it as an integer. So let's say value can all of a sudden turn into index 0. You remove those 5 bytes, that string, and replace it with a single integer, and you're going to save space there. Now think about if you multiply that by however many entries you have in your cBor, you're going to save a ton of space. But that is all contingent on the other side that's receiving the data to actually be able to parse it into structured data that it knows on that side, and it knows what index is where, so it knows what data it is. But we'll be sticking with the strings for now, just as the example. But it's something to just know about. It's like, oh, packed cBor. I think I know what that means. Like it's even more optimized than what this is. Let me see back here. So in the end, this gets you a 10-byte payload. And again, the memory is allocated. It's statically allocated, so no heap, no need to deal with that funny business. And you can actually see the hex representation if you just print it out. Or you can actually look at, like, you can use a site like cbor.me to actually test your cBor, or look at the payload, or convert it back and forth between a kind of a JSON representation and cBor. So cbor.me, and then this is actually the value. You can see those 10 bytes there. And you can see the comments here that are actually showing what each what each byte actually represents. So it's like, hey, we're setting up a map. I have a piece of text with a value, and then we have a and then like an unsigned integer of 1, 2, 3, 4. And then it goes on that left side. That's the exact representation in JSON. So you can kind of see, you can swap back and forth. You can test it. You can play with it, just to make sure that you are getting what you want. And then on the server side, you can also do that too, or you can set up your codec. You can set it up to encode some things, and you can send it over the pipe and see what comes out on the other end. So, but that is about it. Let's see, we got some comments here. So no urgency in answering, but curious about advantages of a QCbor versus Protobuf. Thanks, Martin, for the question. So I've also used Protobuf significantly. A good chunk of stuff that I've built uses Protobuf. The nice thing about QCbor is that it's just a little bit more flexible. It's basically kind of like an optimized version of JSON, where it just doesn't have all the extra fluff. It really just comes down to your preferences. Either way, you have to basically set up. So for Protobuf, you need to basically create your definition, and then definition gets compiled into precompiled libraries that can talk to each other. So I can create a library, a Protobuf definition, and then I can get the C code, and I can get the Rust code or the Go code, and then they can kind of talk back and forth to each other. And a lot of people love that, and it's really great for talking back and forth and from different devices, and not really having to worry about like the implementation of the library. For me, I like the flexibility of being able to. The nice thing about why I use cBor more often is because in Rust, typically you're setting up structs that you can basically just mark as a struct that can be used as can be decoded or encoded as cBor. So all the work is done on the Rust side, and then because QCbor is so easy to use, I just create the codec side on the device, and then it's pretty much complete on both sides. It's really up to you on how you'd like to serialize your data, but Protobuf is also another very valid option. Captain Proto is another one. Message queue. There are a ton of them, and I think I've actually done some posts on some of them on my website, so jaredwolf.com/blog. And then if there's things, if you'd like to see more like Zephyr and Protobuf or any of the others, feel free to leave a comment and let me know, because we could always go over that a little bit too. But as of late, I've just been using a lot of cBor, and then cJSON as necessary. So some clients talk to some services and they just use JSON. They're still kind of behind the ball in terms of being kind of I don't know how to say it, efficient with their data usage. So for instance, like services like UBDots, they don't have any type of cBor or anything, unlike services like Goliath, where they're cBor first. So you're packing data as cBor, and their service accepts cBor as a kind of first kind of number one option versus like JSON or whatever. So hope that helped. And that is about it. I'm just going to wait to see if there's any more questions before I take off. Hey, Christopher. Is MQTT with QCbor an option? Any other message queues to build on QCbor? So that's actually what I'm using a lot right now is I have a Rust backend built and it runs MQTT. And what I do is I encode the data using QCbor, and that goes right to bytes. And basically what I'm doing is MQTT, you can just basically say, hey, I have a payload of X amount of bytes. And then I just send that payload as is. There's no restrictions on like sending. So some services, like you need to send a string. And it's like, ugh, I don't want to send a string. I want to just send bytes. And here's the size of the bytes. Like, don't. So MQTT, you can actually send a specific, hey, I want to send this payload. This is the size of the payload. You don't need to know what the payload is. And then on the server side, it receives it, and it's like, okay, if I'm listening to this topic, it's going to have some type of cBor, and then I decode it on that end. So 100% you can do it. I recommend it. Definitely play around with it. But from me, I've done it a bunch, and one of the kind of like libraries, the server stuff that I was mentioning, this is called Purinus. It's not in the description, but I'll add it, and you can just kind of see how I did it. The client is on Zephyr, and then the server is all Rust. So cool. Martin, yes, thanks. Cool. Okay, I'll wait if there's any more questions. Hopefully that answered your question, Christopher. Any other message queues to build on QCbor? I hope that answered your question. So wait for any more questions. I know there's a time delay. Live TV, right? Hey, Franz. Cool. All right. Well, if you guys have any requests or questions or things that you're thinking about Zephyr, I'd be more than happy to do the next live session on it. Just send it my way so I have enough time to think about it over the next week. And I hope you all have a really awesome week and great Zephyr Tuesday. Oh, yeah. All right. Thanks again for joining. I really appreciate this. The live sessions always make me smile because it's always cool to kind of interact with you guys. So